Hi, this is Mohit from Team Spartans, and this is a small introductory video to the solution that we have prepared, which we like to call DexMind, which is an AI powered ticket routing system, but it's actually not just AI powered. It is something that also learns your infrastructure because it is powered by a knowledge graph. I'll come to the knowledge graph when I give introduction about how the system is working. So let's directly jump into the video in the demonstration part. So this is my credentials. This is what we get when we log in when we first open the page, and after entering our credentials, we can click on sign in. It will take us to the dashboard, and in the dashboard, because I'm an admin logged in as an admin, I have the option like dashboard. I can create new ticket. I can chat with the AI also. This feature is actually under development right now. Then we have these departments, different departments that you see, infrastructure ops. I mean, basically the 6 things that we are working on. Then these are the analytics. It provides a bird's eye view about how the system is performing, how many tickets are landing every day, what is the confidence category in each of the different categories that we have. And these are the different tickets by categories that we have. So the list that you see over here is actually the synthetically generated ticket that we have, through which the system actually gains all its thinking power. And because I'm an admin, so of course I have this user section where I can create new user. Right now we have 2 users, which is one admin, which is me, and then Zainab Siddiqui is another user who is actually an engineer, not an admin, and she is working under access management. Her account is active, but we can also deactivate her. So this is the overall UI thing that we have for the for someone who is admin. Now let me quickly jump to the ticket routing and show how the knowledge graph and things work in the system. So I have something prepared already for a quick demo so that we do not waste a lot of time. So I will quickly put the text over here. So someone is facing some connection errors on PostgreSQL on ProdDB 0, and this is the description that the person has given. Let me quickly open the server logs. So this is the backend server which is running, and let me quickly submit it. So once we click on the submit, in the backend, the system starts to run different services, and then it starts to basically when we submit a ticket, so there is a complete life cycle that the system goes through. So there is the retrieval, there is actually the fetching cycle where the ticket is like fetched to the system. The system converts it into embeddings and stores it in the database and stuff. And after that, after creating the embeddings, the system actually perform 4 different parallel retrieval searches. I will come to that, how those things work. And after retrieving the information, the next stage is the classification. In the classification also, we have 4 different parallel searches that 4 different parallel searches that classifies the ticket and transfer it to the right department. So talking about the retrieval, we have these 4 things that we see: vector search, which is like the normal vector searches, which is common in the AI systems. Then the error matching, which is whatever error code that we have. The full text search is the full text search. And this is the graph traversal that I was talking about. So graph traversal, I would say, is the most core part of the application, because a graph is the central knowledge base which has an understanding about your complete infrastructure, the different entities that your infrastructure has, and how each thing is related to each other thing. So let me quickly show the database, how it's represented. So we are using ArangoDB, which is not very popular but very powerful database, because it is a multi-model database which comprises of JSON documents. It comprises of the normal key value pair database model, and it is also a very powerful graphical database system. And I will explain how we are using this knowledge base. So right now that you see on your screen is the knowledge graph of the system. This is the entire understanding that the system has about your infrastructure. And if I zoom in a little, I'll be able to explain it. So if I come to this, let's take this example. So in the thing that you see on the screen is an infra ops team. So this circle, blue circle, represents an infra ops team. And the system understands through this graph that engineer 04 and engineer 03 are member of this team. So InfraOps team has these two members, and there is something which is managed by this. Let's see what is managed. So yeah, this team is managing prod NFS1 server. So this is a server which is managed by this InfraOps team. And then there is another server also, which is prod web1 server, which is again managed by this InfraOps team. And all these things that you see on the screen is actually contained inside of these collections that you have. We have the teams, the tickets, and the member of, and the engineers, and the category, Centroid. I mean, all these things, all these collection that you see on the system is what is connected by this knowledge graph, and that is how the knowledge graph is understanding a system. And this is not a static kind of knowledge graph. It grows along with when the new changes come inside the system. So it grows and it make changes. So it adapts to whatever changes there are in your infrastructure. So coming to the ticket. So if we read the text of the ticket, I mean, most of the AI system will be able to make sense of it. Like PostgreSQL is not working, is not accepting connections. So up until this part, it's fine that it's not accepting some connections and Postgres. So AI will be able to make sense of it, but AI will not be able to understand what does prod db02 mean, because prod db02 is something which is very specific to only your organization. It is not like available anywhere else. And to make sense what prod db actually means, we have this knowledge graph. So knowledge graph, what it does, if I go back to this log, so what it does is it traverses through the entire graph, and it finds that there is a server prod db02. The team is database admin. There are 5 past tickets and there are 2 experts. So this is what the information retrieved by the system, and all this entire information that the system has retrieved is fed to the next stage. The next stage that I was talking about is the classification stage. In the classification stage also we have 4 stages, which are the LLM. One is the LLM, the other one is the KNN, the third one is the Centroid, and the last one is the keyword. So it is not just one classifier that we are relying on. There are 4 different classifiers on which we are relying on. LLM is the QN 2.5 model. Then the KNN is the kth nearest neighbor. Right now we are, basing our classifications on 5 similar nearest neighbor. Then we have Centroid, and the keyword search is like the normal keyword search that we have. There are different weights which are given to this. LLM is weighted highest, which is 40%. KNN is 30%, Centroid is 20%, and then keyword search is 10%. So now the system has also completed the classification. So let's go through what the system has actually done to the ticket. So we see that the ticket is actually routed successfully. The system has decided that it's a database ticket with 99% confidence. I will explain how we are calculating this and how this database is getting decided. Then this is a high priority ticket as decided by the system. Then the team is database admin. The expert is Meera Patel. So all this information is coming. Meera Patel, database admin, is coming from the knowledge base. And this is the input quality because we provided a lot of good quality text inside the ticket, like prod db02 and other stuff, which the system understands and can traverse through the graph. Now this is the AI reasoning, that what the AI think and what is the reason behind this classification. So this is what the system has classified, that the title and description indicates PostgreSQL on prod 002 refusing new connection, and whatever like the system thinks, and that is why. So the person who is looking at the system can also see that if the system is working correctly or not, because we can look at the AI reasoning, that what the reason the system is providing. Then this is the suggested resolutions, which are again coming from the runbooks and routing rules and resolve within resolution, all these things. So the system is referencing those things and then providing a resolution. So again, it is given 95 effective because based on the similar past ticket, the system finds that these resolutions which it is suggesting were 95% effective. And then this is the runbook that it has referenced, which is PostgreSQL connection. And these are the recent tickets that, they were there. So previously I created this firewall blocking ticket. So it was also routed successfully. So now we can go to the dashboard and have a little more information about this ticket. So when I click on PostgreSQL, so this is the AI reasoning that AI has given. And these are the 4 AI classifiers that I was talking about. So we see that there is a 99% confidence level because LLM thinks that it's 100% database. KNN also thinks that it's 100% database. Then Centroid thinks that it's 99% database related ticket, and keyword search thinks that it's again 100%. Now let's say that LLM thinks it's 100%, KNN thinks it's 80%, Centroid thinks it's 70%, and KNN thinks it's 0%. So based on the different votes that we get from these category classifiers, we have a system which performs which is actually like a mathematical thing that we are using in the system. I'll not go into the detail about that, but it aggregates the votes of all these 4, and then it generates a confidence level, because right now we're getting like very near to 100%. That's why it's like 99%. But in certain cases, we are working on this. We see that sometimes it gets like 75%, 78%, or 85%, 86%. But if it's more than 70%, we consider that the system was able to make like a correct decision, and the system automatically routes it. But in case if not, then the system escalates it. So this is the how the system is currently working. Now I can actually click on it. I can pick it up. I can click on pick, or I can escalate it. If I click on pick, then I can click on resolve. I can resolve it with the solution that I can provide. I can click on resolve, and I can click on resolve. I can provide the solutions, or if I close it and log out, and if I log in with a normal user, then this is what I see as a normal user. So we do not see like all the tickets that we have in the system and everything. So because Zainab is in access management, so she will only see the tickets which are, related to access management only. So coming back and to Mohit again. So yeah, this is the overall way how the system is working. So to summarize, it is not just the AI that we are using to classify the tickets, because AI can't make sense of things which are very specific to your organization, like prod 02 or things like that. Of course, it's a RAG system, which is retrieving and then augmenting the generation. But yeah, for retrieval and augmentation, we are using the knowledge graph. The knowledge graph understands your entire infrastructure. It makes sense of it, and then it feeds to the LLM model and to the 4 different classifiers. And then that is how the classification is working. So in the retrieval part, we have 4 parallel running processes. And in the classification part also, we have the 4 parallel running processes. And yeah, so this is about how the system is performing all the classifications and it's working. Yeah, thank you.